So again, a very good question, rotting oranges. So this is a medium question, and you are given an M cross N grid. Grid means a 2D array. We each cell have a one of these three values. So 0 represent an empty cell, means that cell is empty. See, this is an empty cell, this is 0. One cell is representing it is a fresh orange, and 2 is representing that my orange is rotten. Every minute, any fresh orange that is adjacent to my rotten orange become rotten. Suppose this is a rotten orange and it has a fresh orange adjacent to it. Adjacent means left, right, top, bottom. Okay, so if it has a fresh orange adjacent to it, that orange will become rotten next time. Okay, next minute. Return the minimum number of minute that must elapse until no cell has fresh orange. If this is impossible, just return -1. Suppose we have done this rotten game and at last our grid has some fresh orange, then we will return -1, because why this fresh orange is there, every orange should become rotten. And suppose each orange is rotten at last, so we will just return how many minutes it took. Okay, so see, this grid took 4 minutes to make every orange rotten, so that's why we will return 4 here. We will return 4 here. Okay, and so first I will write code for it and then I will explain you. Okay, so we will make a queue here. Why queue? Because we have to count how many rotten orange are initially there in my array, and then we will start that rotten game. So I'm making a queue of what? Vector of int, and yes, this is my queue, and its name is queue only. So let me explain it to you. So we will make a queue, and suppose this is a queue. Okay, this is a queue, and we will do what? We will just push its index of this orange, 0 comma 0, to our queue. Now we will check till our queue is not empty. We will make each of adjacent orange to this orange two rotten. So this was an adjacent orange and this was an adjacent orange. So we will make them rotten and we will pop it out and we'll push its index. See, index of this orange is what? 0 comma 1. Yes, and its orange, this orange index is 1 comma 0. So we'll push 0 comma 1 and 1 comma 0 into this array. Okay, into this stack. We have pushed it. Now we will make each orange adjacent to this 0 comma 1. 0 comma 1 is this. We'll make these two orange rotten and we'll push their index as well, and we will pop this out. We will pop this out from. Now we will do again with this, and at last our stack will become empty. At last our stack will become empty. So, and that's our answer. We have to count how many minutes it took, and if there is any fresh orange, we will return -1. So let this is my queue, and I'm making n is equals to grid dot size, grid dot size, yes, size, and int m is equals to grid of 0, uh, grid of 0 dot size. Yes, perfect. And I will start my logic from here. For wait, uh, int I is equals to 0 and I less than n, so I plus plus, and for let j. So we are using double loop because we have 2D array. Yes, in 2D array we can only use double loop to iterate through it. M j plus plus, again j plus plus, and if there is any orange rotten, if I have any orange which is rotten, so how can I check that is this a rotten orange or not? I of j. If grid of I of j is equals to 2, means this orange is rotten and I have to make it into my stack. I have to push it into my queue, not stack, sorry, uh, queue. So queue dot push is simply like this, queue dot push an array of I comma j comma minute. Why I'm pushing minute? This is a BFS approach. I have to take that count of that minute each time. So I'm pushing that minute. Is initially this is 0 minute. If you cannot understand this minute concept, leave it. I will explain it to you afterwards. I will write this code. So while, now I will write this while. Oh wait, while q dot q dot empty, q dot empty. Is my queue empty? Empty, sorry. Yes. if q is empty, while q is not empty. So I have made a not symbol after before it. So this means till q dot empty is false. Okay, till q dot empty is false. Suppose my q has something, so we have to do it like this: vector of int only, and this is front. Why this is front? Because now we will extract q dot front, q dot front, not w. It is q dot front, and I will extract this q dot front, and I will do q dot pop. Very simple. Now I will extract 0 and 1 and 2 of this q. So see, 0th index we have I. So I will make a variable int I is equals to front of 0. Yes. And just like this, I'll make j is equals to front of 1. Front of 1. Okay. Front of 1. And I will take time is equals to front of 2. Yes. And now I'll write my logic. So our main logic starts from here. If top index, how can I extract top index? Suppose my right now I have 2 comma 2 as my index. So its top index will be 1 comma 2. So I will do I minus 1 grade of uh, so writing for this question is a little tough. I minus 1 of j. J will remain same. J will remain same, and is equals to fresh. If this is fresh, make this a grade of I minus 1 of 2 of j, not 2, sorry, very sorry, of j is equals to 2. I'll make this rotten, and I'll push q dot push this I minus 1 array of this. See, you can also make this mistake: I minus 1 comma j comma minute plus 1 or time plus 1. You can write like this: minute plus 1 or time plus 1. Yes, so we have done it. So now we have done it for top index only. Now I have to do same task for my bottom index. So I'm copying this code, and I will change it bottom. So on, see, there's one more condition. Suppose my I is less than 1, I is 0, so it will try to extract grid of minus 1. That is not possible. Minus 1 comma j, that is not possible. So I should be greater than 0. I should be greater than 0, and this code will happen. And suppose I have to extract bottom index, so I have just to write grid of I plus 1. And for this I plus 1, I can go up to my bottom index only. My bottom index is 2, so I grid of I can maximum be 2. Okay, so grid of I minus 1 can maximum be true 2. I plus 1, grid of I plus 1 can maximum equal to 2. Okay, this can go up to 2 only. So I will write I should less than uh, n minus 1. Why n minus 1? Because n is 3 and 3 minus 1 is 2. So I is less than 2 means I can only go to 0 and 1. And if I is equals to 1, so this grid will become grid of 2. Yes, you can imagine. Can you imagine it? So I plus 1, I will make this rotten. I will make this orange rotten, and I will push grid minus 1 comma j comma time inside my array. Now I will do the same for okay, my right index. Right index is what? Grid of, first I should do it for my left index. Grid of I will remain same for left index, and j minus 1 will uh, change. J will change, I will remain same. And if j minus 1 means we are here left index, so if left index is equals to fresh, I'll make this rotten. Grid of I comma j minus 1 is equals to rotten. Rotten means 2. Okay, and q dot push an array of, see, array of j minus 1 comma time plus 1. Yes, we have to send it each time. Okay, and for this again j should always be greater than 0, and same condition again. So doing this thing is easy. Now you just have to copy paste your own code only. So this thing is easy. J should less than m minus 1, and j plus 1. This is for right index only. Okay, so grid of I comma j minus 1, and this is plus 1 time plus 1. And see, our time will become, I will make a time count variable after it. Time count is equals to 0, and time count will be maximum. Time count is equals to uh, max of time count comma time. Yes, it will be maximum of both of them. So okay, this code looks good to me. And now I will check. After doing all this thing, is there any fresh orange left in my array? So for this, I will copy this code. I will copy this code and format also my code. So if any orange left rotten, so if any orange is one, just return -1. See, it was returning -1. Return -1. Else return wait, return time count. Okay, so this is an array. Oh, sorry, this is the answer. And see, if there's no, see, after this whole rotten orange game, if there's any orange fresh left, we'll just return -1. So this code looks good to me, and shall I run it? Okay, I'm running it, and let's see, will this give me? Okay, so okay, we are not using JavaScript, so I should write int. Sorry, that's my bad. And here also int. It should be int. And is there any other error? Runtime error. So are we making any mistake? So q dot runtime error addition of offset. Okay. So let me see, why is this happening? J plus plus I is less than m, j is less than n. Grid dot size, grid of 0 dot size. Okay, again, if grid of I comma j is equals to 2, push that into my array. Time is this. While q dot empty is false. Okay. While q is not empty. Okay. Till my q is not empty. Okay, q, we are extracting front of this q, and we are doing q dot pop, and now int I is front of 0. Okay, front is an array, q is a vector. Okay, j time is the front of 2. Yes, and time count is max of time count comma time. Okay, I got it. We are not including bits and that all. We should include it. Hash include. So for using this max function, you should include that bits slash stdc plus plus dot h, and we are using a what? We are using what? Namespace space std only. Yes, std. Yes. So now I think this will work, and this should work now, because I don't see any error. So again, a runtime error means we are making again some mistake here. So can you see this mistake? I cannot right now. Let me see. Time count is equals to max. Time count comma time. Okay, this is correct. This line is correct. Time. This line is also correct. Vector of int front. We are using q dot front. That is a correct function. Q dot push is also a current function, which we are doing it here. If maybe we are doing something wrong. Okay, we are pushing I comma j, and now we are checking if q dot and I should also do something like this is not equal to true. Okay, q dot we will take its front. We will do q dot pop. I is front of 0. Okay, j is front of 1. 0 1 2. Okay, that's fine. I greater than 0. Grid of I minus 1 is equals to this is 2. Yes, again this is good. I minus 1. If I less than n minus 1. Okay, and we are doing it I plus 1. Perfect, this is also good. And if I plus 1 comma j is equals to 2. Okay, is 1, we are making it 2, and we are pushing its index. I plus 1 j time plus 1. Perfect. If j is greater than 0, now for j we have to do the same task. So if j is greater than 0, do this. Okay, perfect. J plus 1 is equals to 2, and we are pushing it time plus 1. If j is less than m minus 1, okay, I can not see the error. If j is equals to 1, okay, j is 2. Okay, I can see it now. I can see it now. And j of time plus 1. Yes. plus 1 minus 1, yes. So now if I run it, oh, this should run now. Okay, I couldn't handle it anymore error now. So it ran. So we are just doing some mistake there. And now I think this will run perfectly fine. Okay, so see, our code is accepted. So writing edge cases for this question is quite tough, but otherwise that this question is not that tough. Thank you so much.